Hi everyone, today's topic is frame of reference. That is a very important topic in kinematics, and we'll see how important it is using your Newton's second law of motion. And say a lift is there, a mass has been hung, and say the mass is m, and here the string has a tension, take it as t. Now, if you're seeing from the ground, from the ground, say this lift is moving with an acceleration a. From the ground, if you notice this one, if you draw a free body diagram for this particular mass and the weight will act downwards, it will be equal to mg, and tension will act away from the surface, which will equal to t, and if you it is accelerated a. And free body diagram, your Newton's second law says F net on a system is equal to mass into acceleration. And here, what is the F net? You can say T minus mg or mg minus t, whichever the highest. And if I say mg is greater, we can say mg minus t is equal to ma, mass into acceleration. Okay, and this is Newton's second law of motion. And say you are going inside this lift, your reference is changed, your frame of reference, now here it is ground. With respect to ground, you are saying now you're inside this lift, and now you are drawing a free body diagram for the same mass. The tension will act upward t, and if you see here, this mass mg, yes, and tension will act upwards t. And what is the acceleration with respect to us inside this particular lift? Your acceleration will be 0, a will be 0. And so if you write free body diagram and say mg is greater, mg minus t will be equal to 0. So we can say it as t is equal to mg, and this is wrong. This is wrong. This is correct. This is wrong. And so the frame which we select is much important in your kinematics. Say for this equation, what we can do is we can apply a pseudo force. If it is accelerating upward, we will equate with a pseudo force, that is imaginary force. Those things not needed in this particular class. And how important the frame of reference is for that particular point, it has been seen. Okay, in ground, this is true, this is correct equation, and this equation is wrong. If you're going inside, the frame varies. If the frame varies, your equation also varies. This is wrong, this is wrong, and so much important this frame of references. Okay, now we'll see what is the frame and how it varies, and those things we can see using a small example. Now, what is frame? A frame is where from we look at the things. Say a train is moving. If you're standing outside and looking at the train, you can say, for example, train is moving at 100 meter per second. If you're seeing from outside, and you can say it is moving at 100 meter per second. And same if you go inside the train, and if you're sitting, and if you will feel like that train and you are in the same place, train will not move without you. The displacement will not be available. You can feel, right? And if your friend is sitting nearby you, and if you're seeing a friend, and always your friend will be in the same distance, he is not going to move inside the train. And if your friend is sitting inside and you are standing outside and you're seeing your friend will be moving. That is frame of reference. And which frame you are saying, the things and values will change. Okay, that is very important while considering your any motion particle, in motion. That is kinematics. In kinematics, it is very, very important concept. And to explain, to properly understand, we can take three situations. And first situation, we are standing in ground. This is ground, and one car is there. Say The car is moving with an speed of 50 meter per second, and we have an aircraft, and aircraft can draw an aircraft. It's a rough diagram, bear with my diagram. Okay, this is an aircraft. It is moving in this direction with a speed of 300 meter per second. Okay. Now you are in the ground. You can say that the car is moving in 50 meter per second towards the lift, towards the lift. Okay, and if you see the aircraft above the sky, it will move 300 meter per second in the right direction. From this reference, from your ground. Okay, and if you say, take an example of trees there, and you are seeing tree with the tree will be at 0. If you're in the ground, you're standing in the ground and you're watching all things over here, the car will move at 50 meter per second. Yes, it is moving in 50 meter per second. If you're seeing aircraft, it is moving 300 meter per second towards right. Yes, it is also right. And seeing your tree is in rest, always it is in the same position, it does not move. Okay, and you're observing things. Now what you're doing is you're going inside this. Your situation is different. Now say in this situation, you're inside the car, and car is moving in 50 meter per second, and a tree is there, and also the aircraft flies. The same 300 meter per second. Now your reference is different. First it was ground, and now the reference is inside the car. Car is your reference. Comparing to the car, that is with respect to the car, your speed is now 0. Comparing to the car, your speed is 0. That means your car has 0 speed, moving in 0 meter per second with reference to this frame. You can observe, and if you see the ground, that is the tree, now it is moving towards right, and if you observe the tree, and the tree will be moving, it is not moving, it seems to be moving 50 meter per second opposite to your speed. Okay, and you can say a tree moves with a minus 50 meter per second. Can you understand what I'm saying? You are taking this as positive. If you move this side and tree is moving towards your right, you're moving to left and tree is moving towards your right, it seems to be moving, in 50 meter. Now in the same situation, take you're sitting inside the aircraft. We are sitting inside the aircraft. Aircraft is moving 300 meter per second, and your car is there. Now the frame of reference is aircraft. You're inside the aircraft. The car is there, and the same tree you're observing. Now if you observe here, the aircraft, that is airplane, aircraft, whatever, this the speed of that will be seem to be 0 meter per second. Yes, you're sitting in the plane and the plane is moving the same place. You're not displaced, that is, there's no displacement between you and the aircraft, or the place where you're sitting remains there itself. It is not moving anywhere, and that we call it as this. Now we can say aircraft is seem to be at 0 meter per second. It has no speed. Okay, if you observe from there, this car which is moving 50 meter per second towards your left, and it will be like moving like here. This is 50 already, and this is moving 350. The car speed now will be looking like this. It seems to be 350 meter. If you observe from there, you can see us watching the car, and car is moving at 350 meter per second. Actually it is moving in 50, but while your reference is changed, you can observe, or you can see, the car is moving in what, 350 meter per second. Understood, right? 300, and this is moving opposite with 50 meter per second. It both will be added. And if you observe this particular tree is in rest, we know, in the ground. with respect to ground, it is with respect to ground, it is in rest. And if with respect to this aircraft, if you see the tree speed is found, or it will be seemed to found as 300 meter per second. And this is where this particular frame of reference will be much important in the bodies and motion. Okay, hope you understand, and thank you for listening.